Welcome to our exploration of large language models, or LLMs, the technology that's revolutionizing how we interact with artificial intelligence. Today, we'll uncover how these fascinating systems work, from their basic architecture to real-world applications. Whether you're a student, developer, or just curious about AI, this journey will help you understand the future of human-machine interaction. Modern LLMs are in large part the result of the most influential papers in modern artificial intelligence. Attention is All You Need, published in 2017. This groundbreaking work introduced the transformer architecture, which revolutionized natural language processing. This paper presented a completely new architecture that would become the foundation for modern language models. The paper was a collaborative effort from an exceptional team at Google Brain and Research, led by Vaswani. These researchers would go on to influence the entire field of machine learning. This paper has garnered over 100,000 citations, making it one of the most referenced papers in artificial intelligence. The impact of this paper cannot be overstated. It laid the groundwork for revolutionary models like BERT, GPT, and T5. The paper's self-attention mechanism transformed how we process sequential data, completely eliminating the need for recurrent neural networks and convolutional neural networks in many applications. This paper stands as a testament to how a single innovative idea can reshape an entire field. The transformer architecture continues to be the backbone of modern AI language models, proving that sometimes attention really is all you need. Let's dive into the heart of an LLM, the transformer architecture. Starting with the input text, the model first converts words into embeddings, creating rich numerical representations. These embeddings then flow through multiple attention heads, which work in parallel to capture different aspects of relationships between words. The feed-forward network processes this information further, while layer normalization ensures stable learning. This elegant design allows the model to handle complex language tasks with remarkable efficiency. The attention mechanism is what gives LLMs their impressive ability to understand context. When processing a sentence like, "The cat sat," each word pays attention to every other word, creating a web of relationships. The strength of these connections, shown by these lines, determines how much each word influences the interpretation of others. Notice how words can attend to both nearby and distant words, allowing the model to capture both local and long-range dependencies in language. One crucial challenge in language processing is maintaining word order. This is where positional encoding comes in. Using a clever combination of sine waves at different frequencies, each position in a sequence gets a unique mathematical fingerprint. The lower frequency waves help distinguish broad positions, while higher frequencies provide fine-grained position information. This elegant solution ensures that "the dog chased the cat" and "the cat chased the dog" are understood as very different sentences, despite using the same words. The transformer architecture is the engine behind modern LLMs. Think of it as an assembly line for language processing. At its heart is the attention mechanism, a sophisticated system that helps the model focus on relevant parts of the input, much like how we focus on key parts of a conversation. The feed-forward networks process this information, while layer normalization keeps everything balanced and stable. Each component plays a crucial role in understanding and generating human-like text. Training an LLM is like teaching a child to read and write, but at an unprecedented scale. During pre-training, the model learns from billions of text examples, developing a basic understanding of language patterns and relationships. As we track the learning curve, notice how both training and validation performance improve over time. The fine-tuning phase then adapts this knowledge to specific tasks, much like a professional specializing in their field. Let's examine how LLMs improve during training. The green line shows training performance, while the red line represents validation results. Notice these key milestones: initial convergence, where the model begins to make sense of patterns; mid-training, where it refines its understanding; and the final phase, where improvements become more subtle. The gap between these lines tells us about the model's ability to generalize to new situations. LLMs have transformed from laboratory curiosities into practical tools that touch nearly every industry. From generating human-like text and completing code to enabling natural conversations and conducting research, these models are reshaping how we work and communicate. Each application connects with others, creating a web of possibilities that continues to expand. Thank you for joining us on this journey through the world of large language models. We've covered their fundamental architecture, training process, and real-world applications. As AI technology continues to evolve, understanding these concepts becomes increasingly valuable.